Okay, or I can record, like I can post the next class's recording for you if you want. Okay, so that's 16. 17. 5% of adults participate in at least 30 minutes of exercise each day. Wow, 5%. I am not part of that percentage. I don't know about you guys. I keep telling myself, yeah, I'm gonna exercise. I have an elliptical. I have like no excuse and I just don't do it. Okay, so how likely is it that a randomly chosen adult will exercise 30 minutes each day? Okay, so 5% is really small, okay? So it's really unlikely because it's closer to zero, right? I don't know. I don't know what it is. Like, why can't, about that, I just feel like I give myself all these excuses. No, I'm a parent. I'm taking care of my kids. No, 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 no.
You have too many classes to worry about, honestly. Like,
I know, but like when I was at in college, I was very much the same, if not more busy. I was like involved with so many things and running things, and I started a nonprofit organization, and I had meetings and
what
all
the?
stuff. Yeah, and I ran 5 miles every day.
That's crazy.
I know, I was crazy. So then I think like, well, if I could just get back to that, like the running part, it just gives you more energy.
It's hard though, because like you have to form the habit again, and it takes like a whole month to form a habit after.
Yeah, I know. It sucks. It's okay. I'll get there. I don't know. Okay, so question 18. The general election is today, and volunteers are organizing the ballot. Depending on what part of the city citizen lives, they receive a different ballot. The types of ballots that consist of red, numbered 1, 2, 3, 4, and blue ballots are numbered 1, 2. Let R be the event of drawing a red ballot, B the event of drawing a blue ballot, E the event of drawing an even number, and O the event of drawing an odd. So drawing the blue 2 is one of the outcomes in which of the following events? So we need to select all the possible correct answers. So either you have red or blue in terms of color, and then you have even or odds in terms of number, right? So a blue ballot, so here this has two characteristics, a blue 2. So a 2 in the blue set could be considered not red, right? So if I have not red, this is definitely part of this category, if that makes sense. Because what's left to select is blue, and in that is the number 2. Okay, so then here you could have something like, because the ballot is an outcome of blue and even, right? So this is B and E, but it's not any of these, right? So the only one that it could technically be in, because this one has blue as part of it, and this is an or, it counts as everyone. So even though it's not odd, it's still part of B, if that makes sense. And because this is an O, it's not selective, so it could be either one. Okay. So this one wouldn't count. Does that make sense? Because it has to be not only blue, it has to also be odd. Okay. So definitely this would not be in this group. But this blue 2 would be part of this group because this is more large. Okay. Questions on this problem? No?
No.
Your silence is encouraging. All right. So question 19 states, let W be the event that a randomly chosen person drinks 64 ounces of water per day. V be the event that they have varicose veins. Place the correct event in each response box to show, given that the person drinks 64 ounces of water per day, the probability that a randomly chosen person has varicose veins. Now, remember that in general, if you say something like this, the conditional probability, it is read as probability of event A given, sorry, I need to do that too early, given event B. So the given part always comes after. So this is the given part, and this is the probability that you want to find. Okay, like the probability that we're looking for. So since this is worded a little weird, but what comes after the given? The given, the condition is that the person drinks whatever water per day, and what they're looking for is that the person has varicose veins. So it's veins, you know, given that they drink this much water. Okay, does that make sense?
Yes.
Okay, good. All right, and then it says here's a contingent. They give us a contingency table, and they say a random sample of 145 students. So if they have a job, and then we need to complete the table. So basically, remember that these add up to here, and this adds up to 145. So you just have to remember how it works. So the row and the total of the row, row total, row, column, column total, and this would be the total, right? The total sample. So 145 minus 102 would be here 43, right? And then you have here 93 minus 66, so that's 27, okay? And then 102 minus 66 would give us what? 36, okay? And 36 plus what gives us 52, and that's 16. Now, if we did this correctly, this should work out. So 16 plus 17, 16 plus 27 is 43, so it checks out. We did this correctly, okay? So just make sure that it's lined up. All right, 21. Okay, so 21 talks about probability. So it says here, the probability that a college graduate is offered a job at a particular company, given that they also completed an internship, is 6 out of 13. If we know that 29 college graduates and 13 previous interns who did not attend college were offered jobs with this company, fill in the diagram below with the number of employees that hire to reflect this probability. So this one's kind of interesting because event A is the college graduates, right? So 29. So we know that the total of 29. So event A is 29 and B is the previous interns offered jobs. So B is 13 total, right? So we're interested in the intersection because once we have the intersection, we know what the rest is, okay? So what are we given? We're given the probability that that a college graduate is offered a job, so a college graduate, given that they also completed an internship. So probability of A given B is 6 out of 13. So remember that this is the probability of is 6 hired employees in A and B, right? So this would be probability of, this is probability by A and B over P of B, okay? So that means that there are 6 in here. And then since there's 13 in the entire B, that leaves 7 here. And since there's 29 in event A, that would leave 23 here, okay? So let's agree, this is 23, okay? Questions on this?
Oh, it's pretty straightforward.
All right, let's continue.
Yes.
Okay, let's continue. 22. Let me fix mine. I said it was kind of interesting. Okay, so 22, given the following events, information about events A, B, and C, we want to know if A and B are mutually exclusive, um, independent, or both. So let's see here. So what do we know? We have probability of, we need to remember what does it mean for something to be mutually exclusive, independent, or both. So what's interesting to us is we have here that probability of B given A is equal to 0, okay? So what does that mean? We can say this, when you have a conditional like that, it implies that the, so remember what P of A, this is the same as saying P of B intersect A over P of A. So we know P of A is something, but the intersection, it has to be 0, right? Because that's the conditional 0. So the intersection is 0, then that means that they're exclusive, right? So we can say that this is mutually exclusive. Now, P of A does not equal 0, so we cannot conclude that they're independent, okay? What else could I say? And then, yeah, so A and B are mutually exclusive. Yep. Let's see. Yeah, because this is not true, and this is not true. This is not true because it's 0. And then, yeah, so that's it. It has to be A. All right. Questions on this?
No.
Cool. So a random sample of math majors taking an introductory stats course were surveyed after completing the final exam. They were asked, how many times did you review your final exam before handing it in to the professor? And the results were displayed in a probability density function. For the variable x, number of times students review their exam, find the standard deviation, and then we round the number to 2 decimal places. Okay, so we could do it this way where you have, let's see here, you can do this here, the number of times. I think we can do this a couple of ways. You can do it the old school way, like where you have, the table, right? That's how Newton shows you how to do it. You take this and then you do x, p of x, right? And then you do another one where it's x minus mu squared p of x. Or we could just plug it in our calculator and do first variable stats. I vote for that. So let's do that. Let's see here. So let's do edit and let's go ahead and enter into our calculators. Oh, I messed up. Okay. Here, and then we have 1/5, 2/5, and 2/5. Okay. So second quit. Stat, calculate. And if we do one variable stats, I wonder if this should give it to, oh, it doesn't, it gives us the standard deviation 2.64. You just have to ignore this domain part because this is the solution, it's 2.64. If you think about it as a population standard deviation. Let's see. I mean, it does work. This is a solution, but I'm trying to think of what's a good way to remember. I guess if we do L1, L2, and then you do first variable stats, and you need to make sure that you use sigma of x. Okay. Does that help?
A bit.
Let's see. because it's a number of times, and then this is like the frequency. Okay, well, let me think about, well, this is the solution. Or you can do it the long way, but I would just do L1, L2, first variable stats, and then use this because it is asking for the standard deviation. That's the easiest way to do this problem. Unless you want to do this, which is also fine. And I guess the only thing I could tell you for this, if you want to do it this way, you're going to need the mu. But remember, mean is the expected value, which would be the sum of this, the sum of x, p of x. Okay. Okay. Let's continue because we still have a whole other part to this. Okay. 24. Casino. So it's the same thing. This is the same thing except that it wants you to find the expected payout. So remember, our expected payout is what? It's the sum of, or you can say, let's say you could say expected value, let's call it that, but it's the same as the mean in this case. So xp of x, the sum of xp of x. So you can just go ahead and do this xp of x and multiply and then take the sum of it, okay? Of this column. So this would be 150 times 0.161. So 150 times this one, and that's 24.15, 2800 times 0.034, and then 105.23 times 0006, 63. Okay, and then we just add those together. So 63 plus 84 plus 24.15. And then you get approximately 171 because it says to the nearest dollar. So it's 171. So technically it's 171.5, but since it's the nearest dollar, 171. Okay. Questions on this? Oh, pretty good.
No questions.
Okay, so then here, which of the following tables show a valid probability density function? Oh, great, and it's kind of cut off, I think. Okay, so A was 0.37, 0.0. So remember the rules of this, they have to add up to 1, right, for it to be valid, and then also cannot be negative, cannot be negative. Or you'd say something like p of x cannot be less than 0. Okay, so if I take A, I'm going to add 0.37, 0.06, 0.01, and 0.56. So 0.37 plus 0.06 plus 0.01 plus 0.56. And then we see what that adds up to. So 0.06 plus 0.01 plus. So then that's going to be 1. Oh, okay, so this is valid, so A. And then what about B? So we have 3 eighths, 3 eighths, 6 eighths. This is 2 eighths, so this is also adds up to 1. So B also is good. And then what else? And so C is 2/5, which is the same as 4/10. So 7/10, 10/10, 13/10, too much. Too large, right? Greater than 1. Okay, so not C. And then D, 1, 2, 3, 6 eighths. This is equivalent to 2 eighths. So yes, you would get 8 over 8. So that's checks. So D. And then for E, you would have 0.04 plus, this is 0.65. This would be 0.96, and then this is definitely over. So this is greater than 1, so no. and then this one has a negative, so no. Okay, so your answer would just be A, B, D. Okay, so all the probabilities have to be between 0 and 1 inclusive, and or else non-net negative, and the sum has to equal to 1. So 26, identify the parameter in the following binomial distribution scenario. The probability of buying a movie ticket with a popcorn coupon is 0.711, and without is 0.289. If you buy 21 movie tickets, we want to know the probability that more than 14 have popcorn coupons, but it just wants to know the probability of success, right? That's the little p. So that's just 0.711. So p equals 0.711. That's pretty much it. Yeah, it's pretty, I don't know how else to say that. So the random variable x has a uniform distribution with values between 18 and 20. What is the standard deviation of x? And then it says round your answer to the nearest thousandth. Okay, so for this, you need to use the formula. So we need to first make sure you understand it's a uniform distribution, right? So remember, it looks kind of like, it's just like straight. The graph looks like a box kind of. So for a uniform distribution, right? So every distribution has like its own like unique set of properties, right? So for uniform distribution, the standard deviation is, and remember you could prove this using calculus, so we didn't. It's just b minus a quantity squared over 12. Or you could say b minus a over square root of 12, which is technically not correct mathematically, but that's okay. So the values are between 14 and 20, so A and B. So we just plug this in. So standard deviation will be 20 minus 14 divided by square root of 12. So when we, so that would be 6 over root 12. So if I, did the radical, sorry, this is 12, you would get 6 root 12 over 12. So in other words, you would get 1/2 times square root of 12, which square root of 12 is 2 root 3, so that's just root 3. But in decimal form, it says it wants nearest thousand. So I didn't even need to do all this. You could have just plugged this into your calculator and you would get a decimal. So it's approximately 1.732 because it's thousands. So that's it for this one. Any questions on this?
No.
All right. So the next one is, given the plot of normal distribution A and B below, which of the following statements is true or are true? Select the correct answers. Okay, so we have here two distributions, two normal distributions, and we want to compare. Okay, so remember that normal distribution, the center is where the mean is. So in this case, they're both centered at the same place. Okay, so the means are equal. So mean of A equals mean of B. So that would be C. And then what else do we know? The standard deviation is different, right? So this one is kind of skinny and this one's bigger. So A would have a larger, like the data is spread out. So A would have the larger standard deviation. Yeah, that's pretty much it. Centers at same place. And then A is wider. Cool. All right, so 29, Alice was told that her reading test score was 1 standard deviation below the mean, right? So you have the mean, and then her standard deviation, her score was like, mean minus 1 standard deviation. That's her test score. So if test scores were approximately normal with mu 86 and sigma is 4, so that would just be that you just have to subtract. So it would be 86 minus 4, that's 82. Okay, one other way that you could have done it, and this is kind of how like Newton will tell you to do it. I did it this way because it was easy to just take away 1 standard deviation, right? And standard deviation was 4. So if the mean is 86, it's 1 standard deviation below, just subtract, okay? But you could have also used a z-score formula. X minus mu over sigma. Because you have, you're trying to find x. So x is our question. We have this, and we have this. Because this is by definition the z-score. Z-score is how far away below or above the mean are you. So in this case, z is -1. So we have x minus 86 over 4. And then when you solve that, you would get 4 times 4 times 4. -4 is equal to x minus 86 plus 86 plus 86. So you see you get the same thing anyway, okay? So I think that if you can understand that this is a lot easier, yeah? The first way. But
Yeah.
if you understand it the second way, that's fine too. Okay, so then question 30, suppose speeds of vehicle traveling on a highway have an unknown distribution with mean 63 and standard deviation 4 miles an hour. A sample size of n equals 44 is randomly taken. And then we're using the central limit theorem for means. So remember central limit theorem for means? That means that our standard deviation for the sample mean, or in other words, the sample mean distribution, is going to be the original distribution divided by square root of n. Okay, and then we have here the original standard deviation, and then we have n, which is here 44. Okay, so what's this going to be? So for our standard deviation for the sample mean is going to be 4 over square root of 44, which is approximately 0.60, and there it is. Okay. Questions on that?
No.
Nope. Okay, cool. The average American city has 50 buses that use green energy with a standard deviation of 5. A city planner is interested in the sample mean number of bases for a sample of 30 cities. Okay, so he calculates that the mu of x bar is going to be 50 over square root of 30, and then sigma of x bar will be sigma over square root of n. So what is correct and what's not correct? So we just said that the standard deviation is the original over square root of n. So this is the correct standard deviation because it's 5, and then the sample is 30. Okay, but this one is that the problem tells us that the average city has 50 buses. So the average is 50. But remember for CLT for the means, the average of the sample means is going to be the same as the average for the population, the mean for the population. Okay, so sorry, this should be an M. This is the theoretical part. So will be okay. So this is the actual, truth. So this is wrong. Okay, because he did this. So he had the mu wrong of x bar, but he calculated this correctly. So that would be B. Okay. Let's see here. And that's it for part one. Yay! Right? That was good, right?
Yeah.
That was like really fast too, so we did it. You guys have any questions about part one?
No.
Let's move on to part two. Just, together. So, where is my part two? Hello. Oh, here it is. Okay. All right, so final exam part two. Okay, let me go to this part. Let's see here. Wait, oh, sorry. I need to just do something here on my end. Right. Is that it? Okay, I guess this is it. All right, question one. A statistics professor recently graded final exams for students in her intro stats course. In a review of her grading, she found the mean score out of 100 points was an X bar of 77 with a margin of error of 10. So let's construct a confidence interval for the mean score on the final exam. So let's see here. So how do we do that? So remember there are confidence intervals. So in order to do this, we need to remember the theory of confidence interval. Okay, confidence interval is the point estimate, be it population or mean, minus the margin of error, comma, and then point estimate plus margin of error, or just E. Okay, so it's nice because we're already given everything. In this case, it would be X bar minus E, comma, X bar plus E. So we already have it. So 77 minus 10, comma, 77 plus 10. So then our answer would be 6787. Okay. And then question two, suppose the number of inches of rainfall each year is normally distributed for a random sample of years. The confidence interval is generated. Find the margin of error. So, so in order to do this, we just have to subtract because remember, if we think about this on a number line, you have your here's this, and then here's your X bar plus E. This is X bar minus E. So if we want to just find the error, the total from here to here, the total distance is twice E, right? So if we subtract, so to find the margin of error, given a confidence interval, so given the CI, the error would just be highest minus lowest divided by 2. Because when you subtract the highest minus the lowest, that gives us this total distance here. And that total distance is twice E. So if we divide by 2, we'll actually get E. Okay, so we have 7.7 minus 3.9 divided by 2. And then whatever that becomes 1.9. Okay, so that's 1.9. So then question 3. In a survey, a random sample of teenagers were asked if they have a sibling. The resulting confidence interval is this. Now, what's the sample proportion? That's the point estimate. Okay, so in this case, my confidence interval represents p hat minus error, p hat plus error, okay? So if you want to find the middle, we look at it like in this way, okay, this looks like this is p hat minus error, this is p hat plus error. Basically, this p hat is the midpoint between here and here, okay? So if you want to find the midpoint, we're basically taking the average of these two, you know? That's if you've taken algebra, that's like midpoint theorem. So p hat will be the sum of the endpoints divided by 2. Okay. So average of endpoints or midpoint. Okay. Yeah, so then this becomes 1.52 over 2, and that's just 0.76. Okay. Questions?
No, not yet.
Cool. Let's continue. So question 4. So a recent survey, a random sample of 199 office managers were asked about overtime, and 76 reported that they regularly work overtime each week. What value of Z should be used to calculate a confidence interval with a 98% confidence level? Okay, so remember that we need to do alpha. So we want alpha is connected to the confidence level. Remember that alpha plus confidence level is equal to 1. So alpha is in this case, 0.02, right? Because it's 98, so the complement of that would be 2%. So that means that alpha over 2 is going to be 0.01. So the z-score that we're looking for is, remember, z of alpha over 2, which is z of 0.01. So the nice thing is we have this table, boom, that's it. So that's our answer, 2.326. Okay. All right, so question 5. The number of square feet per house are normally distributed with a population standard deviation of 137 square feet and of unknown population mean. A random sample of 19 houses is taken and results in a sample mean of 1350 square feet. So let's find the margin of error for an 80% confidence interval for the population mean. Okay, so there is a couple ways we could do that. So let's do the formula, but let's say you forget the formula or something. I guess you could, I'm trying to think. No, let's just do the formula. Okay, so the formula we have here 80%. So confidence level is 0.8. That means that our alpha is going to be 0.2, okay? Because confidence level plus alpha is equal to 1, okay? So remember the formula for margin of error. So margin of error is going to be the z-score times the standard deviation over square root of n, okay? Right. So then what do we have? We have here that population standard deviation is 137. We have here that n is 19, okay? And that's really all that we needed for this problem, except for z. So we need to have the alpha over 2. But if we know that alpha is 0.2, alpha over 2 is 0.1. So z 0.1 is going to be 1282. So we're going to plug that into the formula. So error is 1.282 times, and then standard deviation, population standard deviation is 137 divided by square root of 19. Okay. So then that gives us approximately 40.29, because you have to round to 2 decimal places. Okay. All right, continuing. 6. In a recent survey, a random sample of 320 married couples were asked about their education levels. 41 couples reported that at least one of the partners had a doctorate degree. Use a calculator to find the value of Z that should be used to calculate a confidence interval with a 95% confidence level. Okay, so we need to do inverse norm. So remember inverse norm. Okay, so first of all, let's see here. So we have, this is our confidence level. That means that our alpha is 0.05 since CL is 0.95. Okay, so what's the formula to find Z using inverse norm? So inverse norm, the formula is, remember we do 1 minus alpha over 2 for the area to the left, comma, and then it's it's 0, 1 because it's a z-score, but actually in the calculator, they'll recognize it. If you don't enter mu and sigma, they assume to be 0 and 1. Okay, so they assume it. Okay, so then we just plug that in. So let's see here. So alpha over 2, this is going to be helpful if we just do that. 0.025, so 1 minus alpha over 2 is going to be 0.975, okay? So that's what we need to type in here. So, so we go to second bars inverse norm. So we hit second, no, and then bars, which is, you're actually choosing distribution, and then we hit inverse norm. Right? So then once you hit that, you enter, so it would be inverse norm and then 0.975. So 0.975, so that's it. 1 point, it's rounded to 3 decimal places. So here's our 3rd decimal place, but the next one is a 9. So Z is approximately 1.960, okay? So that's it. Questions on this?
No.
All right, cool. But this is pretty common. Like, I mean, you might have already known this because we keep doing it so much. So, okay, question 7. The following data represents a random sample. Let me just, hold on, focus this really quickly. Okay. Random sample of the ages of players in a baseball league. Assume the population is normally distributed with a standard deviation of 1.8 years. Find the 95% confidence interval for the true mean age of players in this league. Round your answer to 2 decimal places and use ascending order. Okay, so we need to enter L1. We need to enter this into L1 and then find the confidence interval. Okay, so let's go ahead and do L1. Let's see here. What it means to use ascending order, it doesn't mean to put, you don't have to put this into ascending order. It means the answers. So like when you're saying your interval, you're doing lower and then higher, you know? That's what it means. Okay, so let's go ahead and do that. So stat, edit, clear, we go to L1. Oh, God, L1, clear this. 32, 24, 30, 34, 28, 23, 31, 33, 27, 25. Oh, sorry, 25, my bad. 25, enter. Okay, so now we need to do, so first thing we do, so first enter into L1, then second, we need to go to stat, tests. Okay, so that's in here, stat, test, and we're going to do a, let's see here, Z interval. So then Z interval. Okay, then we can either do data or stats. So since it's data, we're doing data, so we're using L1. Now they gave us the standard deviation, okay? So select data. Select data, and then enter, so it's 1.8, and then list is L1, frequency is 1, and then the C level. So confidence level is 95, so that's correct. So then just hit calculate, and they're giving you the upper and lower. Okay, so the lower, we're going to put the lower one first. Oh wait, this is wrong. Wait, let me check my, oh gosh, of course, I probably messed up something here, so edit. So 32, 24, 30, 34, there it is, see, I messed up. I totally effed up here. So if I were you, when I take the final, just make sure that you're entering everything correctly because that's going to screw you over if you don't.
Okay.
That test, the interval, calculate. Okay, boom, that's correct. So 27.58, comma 29.82 because of that 5. Okay, so that's it. Not too bad, right?
Not too bad.
All right, so then question 8. Finishing time for cyclists in a race are normally distributed with unknown population mean and standard deviation. If a random sample of 25 cyclists is used to estimate the mean finishing time, what t-score should be used to find a 98% confidence interval estimate for the population mean? So for this, some of us don't have inverse t, so it's better to use the table. Okay, so n is 25. So remember, degrees of freedom is n minus 1. So degrees of freedom, when you're talking about t-scores, is 25 minus 1. So in this case, it's 24. Okay, so now we have our degrees of freedom. So then our alpha is going to be, it's 1 minus the confidence level, right? Because confidence level plus alpha is 1. So alpha is going to be 1 minus 0.98. So my alpha is 0.02, okay? So then alpha over 2 is going to be 0.01. So remember that these are all alpha over 2. So what we're looking for is t of 0.01. Okay, so that's this one. Okay, so where do they meet? They meet here, right? All right, so that's it. So your t-score is 2.492. Okay, so if you want to use a calculator, we would use inverse t, 1 minus alpha over 2, and then the degrees of freedom. Okay. But I mean, it's the same. You would do the same thing anyways. You still have to calculate degrees of freedom, and all you have to do is just like, where they meet. So I think the table is actually kind of easier in this case. All right, so question 9. A tax assessor wants to assess the mean property tax bill for all homeowners. Here's a sample. We need to find a confidence interval. In this case, we're going to do, there is no sigma given, right? I don't see it. So what does that mean? We need to do t interval. Okay, so this is, so similar process. We're still going to do L1. So let's go ahead and do that. So stat, edit, enter into L1, your data. So you have 1203, 1553, 1299, 1256, 1089, 832, 1730, 84. Oh shoot, see, I'm already effing up. 1730, okay, 1184, 2082, 1087, 2238, 458. Okay. All right. So once you enter L1, so L1 again, and then we do stat. Okay, so quit this, stat, test, and we're going to do t interval. Okay, so t interval. So stat, test, t interval, where you just have the list, frequency, and then the confidence level. The confidence level is 90. So CL is 0.9D. So let's go down here. Oops. 0.90 and then calculate. All right, so that's it. So then our interval is 1138, and we're rounding to 1 decimal place, so that would be 1338.4, comma 1583.7. Okay? So pretty straightforward. Any questions on this?
No, not yet.
Okay, cool. All right, so then, okay. In a recent survey of 150 teenagers, 93 stated that they always wear their seatbelt when they travel in a car. Assuming the distribution is approximately normal, find the point estimate and standard error for the proportion of teenagers that always wear a seatbelt when traveling in a car. Round your answers to 2 decimal places as given. Okay, so this one is, we're doing our point estimate. So remember here, so we have point estimate, or p hat, would be successes over n. So remember x over n. All right, so x n. So that's going to be 0.62. Okay, and then to find, when you're doing the standard error for the sample proportion, or in other words, standard deviation for sample proportion of sample proportion, the formula is p hat, the square root of p hat, and then it would be 1 minus p hat, or q, I guess, and then over n. So in this case, q will be 1 minus this. So 1 minus 0.62 would be 0.38. So then you just divide by n, which is 150. So this sigma p hat, or p prime, which is the same thing, 0.62 times 0.38 all over 150. And then you take the square root of that. And when you calculate this out, you get approximately 0.04. So that's it. Okay. Okay, then question 11. In a random sample about advertising preferences, 17 out of 40 say they prefer print over digital. Use the +4 method to find a 99% confidence interval for the true proportion of individuals who prefer print over digital advertising. And then it says, round your answers to 3 decimal places. And then it gives you a hint, the empirical rule, saying that approximately 95% of the, okay, so this is just a, what's it called, restating the empirical rule. Well, you can do all of that, or you can just plug it into your calculator and do a confidence interval with this information. So let me just, here, there's 2 ways to do this. This is a proportion, okay? But it's a +4. So remember what +4 means. That means that our new p hat is going to be x plus 2 over n plus 4, okay? So we're going to use this. So our new x would be 17 plus 2, which is 19, and this would be 40 plus 4, which is 44, okay? So if I go here, sorry, let me clear this, stat, test, so stat, then test. And what you're doing a one proportion z-test. Wait, no, that's all right. That's all right. You're trying to do an interval. Sorry. Stat, test, 1 prop z interval. Because, let's see here, 1 prop z. Because we're looking for a confidence interval, and it's a proportion. So that's all you need to do. Except that for 19, you hit x. And then for n, for x you hit 19, and for n you enter 44. The confidence level is 99.7, so 0.997, and then you hit calculate, okay? And that gives us everything. So you have here 0.210 comma 0.654. Okay, so 0.654. Technically, let's see, this would be 0.653, but in the solution it says 0.654, and this is because they do it with the formulas and then they reduce, so they're off a little bit. So our answer is technically more correct. So the shortcut is really not super helpful. The shortcut is just like, oh, Z is this because it's 99.7, so it's the highest possible Z. So it corresponds to 3, so then the Z is plus or minus 3, so we use this. Yeah, so you need to, so if you were to do it the long way, first you would need p hat, which we do, 19/44. And then you would need to calculate your error, which is Z alpha times the square root of P prime times Q prime over N plus 4, right? Because you're doing the plus 4 method. And then we calculate that. So we would do 2.968 times 0.432 times 1 minus 0.432, which whatever that is. 1 minus 0.432, 0.568. And that's all over 44. So once you calculate this out, your error is approximately 0.222. So then when you plug it into, p hat minus error, p hat plus error, because you're trying to find the confidence level, it would be, this is approximately 0.432. So it would be 0.432 minus 0.222, 0.432 plus 0.222. And that's where they get this 0.654. So they would still get 210.654. So, so you see, you get almost the same thing, except when you just go straight to the calculator, it gives you a 3. And that's because of rounding that occurs here. So this is actually more accurate. All right. So we've beat this question to death. All right, 12. Liam wants to estimate the percentage of people who lease a car, and then we need to find, he surveys. So the same, we need to find the margin of error. So the margin of error formula, in this case, right, we're doing it's Z alpha over 2 times the square root of, because we're talking about proportions, P prime, Q prime over N, square root of that. So what is P prime? It's 54 out of 240, because this is N and this is X. So Q prime is the complement of that. In other words, 240 minus 54, 186 out of 240. But if we want this in decimals, probably 0.775, and 54 out of 240 would be 0.225, okay? So now we have everything, except for alpha over 2. Okay, so what is alpha? Alpha is 0.05, alpha over 2 is half that, 0.025. Okay, so Z of 0.025 is right here, 1.96. So now we just plug it in. We have Z of 0.025 is 1.96. So we have Z, we have P, we have Q, we have N. So 1.96 square root of 0.225 times 0.775 all over N, which is 240. Okay? So when you calculate all that out, you'll get 0.053. Okay, so that's it. 0.053. Okay, question 13. Evelyn wants to estimate the percentage of people who own a computer. She surveys 150 individuals and find that 20 own a tablet computer, and then use a calculator. Okay, to find N, X. So we have X is 120, N is 150, and we want to find the 99% confidence interval. So CL is 99. So that's enough to do with the calculator. So we just do one prop Z int again. So clear this. So stat test, one prop Z int, so stat test, and this is one prop Z int. Okay. So X is 120, N is 150, and the confidence level is just 0.990. So let's calculate this. And so our lower is 0.716, and our upper is 0.884. So not too bad. And then 14. Survey of 356 people, 30. Oh, so this is the same kind of question, right? This is the same thing. This is another one prop Z int question. So you have N, you have X, and then you have your C level, 0.95. Okay, so if we did that again, stat test 140, and we have X is 135, N is 356, and our C level is 0.95. You calculate this, and then you get 0.329, comma 0.430 when you round. Okay. Okay, so an SEO account manager is concerned. I think we just did this problem, didn't we? What?
No, but that one was on the test, the midterm.
This test, yeah, because it's more than. So remember, more than means greater than. The direction is specified, it's greater than. I feel like these are from the last exam already.
Ah.
Are they?
Yeah, but it's okay. We could review them.
Okay, so we want to know that the proportion is more than 0.2, right? So that means that our alternative hypothesis is P greater than 0.2, so our null has to be equal to. So that's pretty much it. And then it says here, what is the p-value of a right tail one mean hypothesis test when you have a test statistic of 1.07? So this is 1.07, right? That's the p-value of this. So basically, the table gives us the probability of z being less than 1.07 is equal to 0.858. But the question says a right-tailed, so if we want the right-tailed, this is less than or equal to, fine, 1.07, it's going to be the complement of this. In other words, 1 minus 0.858, which will be 0.142. Okay. And then this one, the following data was calculated during weight loss. We want the test to claim that the average weight loss is less than 10 pounds. So the test statistic is calculated as negative 250, and then the p-value is 0.0062. So what that tells us is the probability of observing a value of negative 250 or less is 0.0062 or 0.62%. And 19, a local marketing firm was wondering an average mall goer spent more than $25. They surveyed his shoppers and received 10 responses. They have the population, so they give you this population standard deviation. And then we conduct a one mean hypothesis test at the 5% significance level. And we want to know what Z and p-value is from the calculator when we're testing whether the mean is greater than $25. So that gives us this. Okay, so we need to do a Z-test. So we need to first enter the data into L1. So this becomes L1. So clear this, and let's go ahead and enter our data. Test that, edit, L1. So we have 25, 43, 28, 37, 26, 46, 11, 16, 20, and 31. Okay, and then we do stat, test, and then we do Z-test. Okay, so let's quit that, stat, tests, Z-test, okay? And then we either have data or stats, but we're entering data. So we need to have highlight data. The mean, the hypothesized mean, the mean for the hypothesis is 25, so that goes here. Then our standard deviation is, 11.2, so 11.2. Then our list is L1, check, and then our hypothesis, our alternative hypothesis is that the mean is greater than 25, so we need to hit greater than. Okay, and then we go down to calculate and hit enter, and boom, there it is. So our test statistic is 0.93, so Z is 0.93, and our p-value, 2 decimal places, would be 0.18. Okay. So that's 19, okay. Okay. So we have here question 20. Winston is a physician who works in a city. He believes the average amount of water adults consume is less than 60 ounces. So here's the claim. Okay, and then to test this claim, he has a random sample of 32 adults. So N is 32. Okay, and then the sample mean is 54. Sample standard deviation test statistic is negative 2.15. Okay, so using this information above and the portion of the t-table below, choose the correct p-value and interpretation for this hypothesis test. Okay, so we need to have here, so the degrees of freedom, how many people? 32. So 32. So we can do, let's see here. So we have degrees of freedom is n minus 1, which is 32 minus 1, which is 31. Okay, and then we want to find where t is negative 2.15. And we want to find the left value. So, so remember the way this works. This is for the right tail, but there's, the thing about this is that there is kind of like a type of symmetry, okay? So it has to be greater than 2.4, but less than 2.453. So this, we're using this right here because it's negative 2.15, but this is the right tail, so it's okay. We're going to use positive 2.15. So it goes here, right? So that means that the p-value goes between here and here. So p-value, so that means that the probability of observing a value of t negative 2.5 or less has to be, so assuming the null is true, has to be between 0.01 and 0.025. Okay, so that would be the first one. See here, because this is the space that corresponds to the value. All right. So that's 20, and then 21. Stats professor gives an exam on performing the t-test with standard deviation unknown. So we need to guess the score. And we need to say, okay, t-test is performed. Okay, so 10 students took the final. The true average exam score was 89.3. To test if the mean guess for the class is not significantly different. So here we go. So we're trying to do a hypothesis test to test if the mean class is not different, significantly different from 89.3. So you have null and alternative hypotheses. So remember the null is always going to have like an equality of some sort. These are all equal, but we're talking about 89.3. So it's either going to be this one or this one. So 89.3. But now it says either, the question says if it's different, right? So that means that our alternative is different, does not equal. So that would be a two-tailed test. So that's this one. And then question 22, we want to know if battery 1 lasts longer than battery 2. Okay, so that's alternative hypothesis. And then the competing batteries are compared. So right away, I could just look at from this, because it says determine if battery 1 lasts longer than battery 2. The only one that fits this is this one right here. So of course the null has to be the contradictory argument, right? So mu1 has to be great. Oh, sorry, this one. Mu1 has to be greater than mu2, but mu1 has to be less than or equal to mu2. Sorry, not that one. This one. So that would be E. Okay. All right. I think this is a similar test like before. This is the same kind of question where you have the test statistic is 0.9 and the degrees of freedom is 208. So we're looking at this row, and then if it's 0.9, so notice that the test statistic gets getting smaller, smaller, smaller. So 0.9 would be like in this way. So see here, if we're going in the same direction, the probability gets gets larger. As t gets smaller, so t gets smaller, p gets larger, right? So then you have a p-value that's greater than 0.10. Okay, and then 24, let's see here, 24. A school district has a standardized test it uses to sort students into magnet schools. Then we have, okay, so then we have a two-mean hypothesis test. And then it says here, we need to do the hypothesis test with the calculator. And where is the data? Okay, so we're doing a hypothesis test with all of this data here, okay? So we need to enter this into L1 and L2. And then we need to use stat test, and it's a two-sample t-test. Why is it a two-sample t-test, you ask? Well, we don't know the distribution, the standard, the population, and we say here, we assume that the population variances are equal. Okay, so we need a two-sample t-test, and variances are equal, so we used pooled. Okay. So we need to highlight that also. So let's go ahead and enter it. So let's see here, second clip, clear, what's that, edit, clear. And then we have 112. So just really quickly entering here. Okay, and then into L2, we enter all of this stuff. So L2, 6. Okay, so we have them all in, and then we need to do stat tests, 2 sample t-test, okay, L1, L2, and then we need to say, okay, what is our hypothesis is that they're different, and then yes for pooled, okay, and then we just hit calculate. Okay, so then we have here the test statistic is t approximately, wait, did I do something wrong? 2 sample t-test. Hold on a second, I messed up somewhere. So sitting correct. So, did I enter these properly? Wait, no, that's correct. See, I was like F up somewhere. So here, 19, 20, 22. Pretty sure that was it, but just in case, because I like totally. Let's see here. Okay, let's do this again. Stat, test, 2 sample t-test. Yes. Okay, fine. Calculate this. All right, there it is. So negative 0.69, and my p-value is approximately 0.492. Okay, so we would fail to reject, right? Okay. All right. 25. Physician wants to test 2 blood glucose meters to see if there's any difference. He measures, identify the null and the alternative hypothesis test. So right away, because it says here differences, it doesn't say greater than, it doesn't say less than, that means that an alternative has to be different, does not equal. Okay, so that means the difference has to be does not equal 0, and the null is that it does equal. So that's this. It's pretty straightforward. Okay, and then 26. We have here a manufacturer of batteries. Okay, so story. Let's see what else do they give us. They're asking us if it's a conclusion, a hypothesis test. So if they're asking us for conclusions, what we care about is the p-value, and we care about the significance level. Okay, so then they gave us that. So basically what we're asking is the p-value, what is it compared to alpha? So we have 0.094, alpha is 0.05, so it's greater than alpha. Okay, so p-value is greater than alpha, so we fail to reject. And there isn't enough, there's insufficient evidence. Sufficient evidence, or evidence is not sufficient to support the alternative hypothesis. So then this one would be, there is not sufficient evidence at the alpha equals 0.05 level of significance to conclude that the true mean difference is not equal to 0. Okay, so then this one, and then it says we fail to reject the null hypothesis. Yep. Okay, and then 27 says, so we have the proportion, and we want to know if state the null hypothesis. We know that the alternative hypothesis is going to be if school A has the lower proportion of students diagnosed with ADHD, right? So 2. That means if we take the difference, that would be P1 minus P2 less than 0. But then the null would either be that it's equal to or greater than equal to. P1 minus P2 has to be equal to, because that's the only null with the equality. That's the shortcut. This one has the equality, so it has to be the null. None of these have an equality, so none of them are the null. Okay, and then 28, in a city known for many tech startups, we have here 31 out of 800. Okay, so we need to do the conclusions again. So it's another one where, hey, tell me the conclusions. So remember, if you're doing conclusions, you just need to look at the p-value and the alpha. So p-value is 0.242. That's definitely greater than 0.05. So p-value is greater than alpha, so we fail to reject. And also, it doesn't support the hypothesis, the alternative hypothesis. So there's insufficient evidence. That's the way this book says, evidence. So we fail to reject, and we say that there is insufficient evidence at the 0.05 level of significance to conclude, and then this is the alternative hypothesis. Okay, and then this one is, again, we just have to, how many cookies does she make? So the profit is 0, so we just put 0. And then we solve for x. So we get 9 is equal to 1.5x. We solve this, and x is equal to 6 cookies. Okay. And then 30 is, what's the pattern? This is just like a positive line because it's a positive slope. Positive increasing, so slope. So you would say it's a linear pattern that's positive. Pretty straightforward. Really not too much thinking on that. So then it wants you to do the linear regression line. So you just plug this in here. So let's click this, clear. Okay, so let's go ahead and enter stat, edit. So clear this and clear this. So x is L1 and y is L2. Okay, so x is L1, so we have 3, 4, 5, 6, 7, 8, 9, 10, and 11. And then for L2, we have 6.03, 9.65, 11.49, 11.57, 12.96, 14.97, 16.31, 0.43, and then 18.45. Okay, so once you're doing that, you go stat, and then you do calculate. So this one's stat, calculate, and we do lin reg. And then what I would do is, because it wants you ax plus b, so then you would hit this one, ax plus b. Okay, so ax plus b, okay, good. So calculate this. So then your a is 1.44 because that's 2 decimal places, 44x plus, and then the b is 3.13. Okay. Oh, sorry. No. Alrighty, and this is the same thing. So except that this asks for b, the value of the intercept. So it's very important that you use lin reg ax plus b. Okay. So we do the same thing. Do you guys need me to do this one, or I could just give you the solution if you want, and then you can test it, or no? So like, or we could just do it. I don't know. It's up to you. It's just getting close to the end here. So let's say stat, edit, edit, and then we clear these, and then we would put 7, 10, 12, 14, 17, 20, 23, 26, 28, 29, 31. And then here we would have 30, 45, 30, 45, 45, 42, 48, 42, 48, 47, 65. Oh no, I messed up here. This is 20, 23, 26, 29, 31. Okay. Oh no, my thing is running out of battery. 65, 78, 87, 85, and then 80. Okay, and then quit this, that, calculate, ax plus b, and calculate, and then your b is just 13.8. Almost at the end. So for this one, remember we're given R is 0.261 and N is 23. But when we're doing linear regression, this degrees of freedom is N minus 2. So we would do 23 minus 2, which is 21. So we're looking at this. So here's my critical values. So my critical values is negative 0.413 and positive 0.413. And then R is in the danger zone. So this is 0.261. So that's danger zone. So it's not significant. So that would be B. And then this one, you would just have to plug in 68 into the line of best fit. So we have the line of best fit, and we just plug in 68. So y hat is equal to 0.1668 plus 45.5. And you're going to get 56.38 when you plug this in, you know. Alrighty, and then 35. Which of the scatter plots have one or more outliers? So you just look at which one of these has an outlier, and it's this one. That's pretty much it. Really straightforward. And then 36. 36 says, which of the following are feasible equations? So I went over this, except that, remember that it's entirely funded by a single donation. So it can't be this, and it can't be this because it's first, the fund has a donation, and then they keep giving out college scholarships. So it's starting with a big number, and then it's subtracting every year. So it can't be this one because it's plus. So it's either this one or this one. Now, because it's 10 years, that means it still holds for 10 years. If you put in 10 here, that's too large. You'll get a negative number. So that cancels this one, so it has to be D. Okay, and then 37. Oh, okay, so I think we went over this too. The SSE, this R squared equals 1 minus SSE over SST. Okay, and then you get that R squared is equal to 0.9021. I guess, yeah, so I guess we could have also just plugged it in and found R squared. Okay, and then I'm almost done, Emma. Yes. So for this one, you need to find out what R is. So we need to plug in, do linear regression again. So L1, L2, and then stat, calc, linreg, AX plus B, right? Once you do this, you're going to get a value for R on the screen, okay? So then once you do that, you're going to get 0.41. I'm running out of time. Okay, so then here, same thing. You're going to find the equation of the regression line. Okay, so we do L1, L2. So L1, L2. And then the same thing here where we do stat. You do stat, calc, and then linear regression. Then reg AX plus B, and then you just plug it in. You're going to get y is 0.03x plus, and then 4323.82. Okay, whew. So we did it. Yay. That only took a long ass time. All right, guys, so that's all I have.